Hi, I'm Grace Goings, and I'm a neurodiagnostic apprenticeship student, and I'm presenting for my class EEG instrumentation on Ohm's law and how it correlates to EEG. So, Ohm's law is I is equal to V over R. I is current, which is the flow of electrons, and V is voltage, which is electrical potential, and R is resistance, which is the opposition to the flow of electrons. So if our voltage, the electrical potential, increases, assuming our resistance stays the same, then our current, our flow of electrons, will also increase. But if our resistance increases, so if our opposition to the flow increases, assuming voltage remains the same, then our flow will decrease. When we are looking at EEG, we are looking at I is equal to V over Z. This is because EEGs are measured in alternating current, which we'll talk about later. So I, our current flow of electrons, is equal to our voltage, our electrical potential, over Z, our impedance. So let's look at impedance. Impedance, this is the equation for impedance, is the square root of resistance squared plus the difference of inductive reactance and capacitive reactance squared. So in EEG, we're looking at Z impedance instead of R resistance because we are using alternating current. So the reason we're using alternating current in our conventional clinical electroencephalograms is because, one, we're able to take into account all of the factors that could be preventing our machine from displaying an accurate voltage, but also two, because using alternating current allows us to not polarize our electrodes. In DC current, we're polarizing our electrodes because the electrode closest to the negative pole becomes negatively charged, and the electron closest to the positive pole becomes positively charged. So it's not able to pick up the underlying EEG signal. That's why we use alternating current to measure, which is why we use impedance instead of resistance. Thank you so much for listening. I hope you learned so much about Ohm's law and so much about how it correlates to EEG.